Hello YouTube, this is my first video on a module that I'm doing on probabilities. And so after watching this series of videos, you should be able to explain or describe a few things here. Starting with, in this video, we're going to be discussing what we mean by the sample space for an experiment. But in future videos, the other things we're going to be exploring are theoretical probabilities and theoretical probabilities versus I guess, experimental probabilities. And those are the two main types that we're going to explore, theoretical, and I'm just going to write experimental probs here, but I mean probabilities. And then the other thing we're going to do within theoretical probabilities is we're going to explore something that are sometimes, things that are sometimes called geometric probabilities, but they're just it's sort of another form of a theoretical probability that we use areas in order to determine. So this being the video on sample spaces, let's go ahead and get into what we mean by the sample space for an experiment. So we say that a probability experiment is some sort of action or trial. Sometimes we use the word trial to indicate this, that has varying results. And often they're a result of random processes. So random's a key thing here with probabilities. We say that the possible results of a probability experiment or some trial that we're doing, we're going to refer to those things as outcomes. So as an example here, it's written, for instance, when you roll a six-sided die, there's six possible outcomes. And we would just refer to these as the 1, the 2, the 3, the 4, the 5, and the 6. But that collection of one or more outcomes, we refer to those as events. And this is a really kind of a weird thing to use, this word event, but we'd say, the event of getting an even number, it would be a collection of the 2, the 4, and the 6 within this entire set of possible outcomes. Or maybe the event that we get a prime number would be the 2, the 3, and the 5, discounting the 1 because 1 is not prime. But basically, we're going to say the event that something happens is the subset of the possible overall things that can happen, or the outcomes of this experiment. What I like here is this. We say that the set of all possible outcomes is called the sample space. And of course, that's what we're exploring in this video. We say, what is the set of all possible things for a probability experiment? That's what we call the sample space. We're going to look at different ways in which we can, I guess, find or illustrate the sample space for an experiment. So what I've got here is just a screenshot of something I found. We flip a coin and roll a six-sided die. This experiment where we flip a coin. We say, here's our coin, it's either going to be heads or tails. And then we have our six-sided die. And we're just going to assume that it's a standard six-sided die numbered 1 through 6. It says how many possible outcomes are there in the sample space and list the possible outcomes. So what you're going to see here, and this is what I like here, we're going to see a situation where if we were to say that this is the initial moment of the experiment, what we're doing is we're using what we call a tree diagram. So we're going to make a little note here, ways to list a sample space. And there are many ways to do this. There are 3 that we're going to talk about here, but one way to do it is to use a tree diagram. And what I want to do is I want to make a little note here. Tree diagrams are very useful when we talk about a sequence of events happening or events happening in sequence. We say that flipping a coin and then rolling a six-sided die, that's when I might want to use a tree diagram because we're talking about a sequence of events. So we say useful when events in sequence. Okay, I don't mean a mathematical sequence, I just mean a sequence. So tree diagram is one way to do it. And the neat thing about this is we say, well, what are the possible outcomes? They say, well, first of all, when you flip the coin, it's either heads or tails. And let's say we do flip a heads, after that we say the die roll, it could be a 1, a 2, a 3, a 4, a 5, or 6. Or the same thing with tails, 1, 2, 3, 4, 5, 6. So what we get is if you look at this here, 6 possible outcomes here and 6 here, it's a grand total of 12. So we get 12 possible branch endings here, and we could list the sample space then just by tracing through each of these elements here. So we have heads and a 1, a heads and a 2, heads and a 3, and that's what you're seeing down here, heads 4, 5, 6, and then all of our tails with 1 through 6. Basically, what you see down here is not a tree diagram, but we're going to refer to this as roster notation because we're just kind of giving a roster of names here. So one way to list these is roster notation. And we're going to make a little note here, but we'd say it's exhaustive. Exhaustive means that you have to use every possible outcome here. And we basically list out each. And usually we separate by commas. So we're going to list things in roster notation from time to time. Let me scroll over here. So separate those by commas. Okay, commas. And so these ways of listing a sample space, I basically want to explore how we could do that here. So let's assume we have another experiment, say this one up here. It says you spin this spinner and flip a coin. Interesting, we're spinning a spinner and then flipping a coin. Would it make a difference if we flip the coin and then spin a spinner? But since these are happening in sequence, we say that there are two things happening. We say how many possible ways exist in the sample space. What we're going to do is we're just going to make kind of a list here using a tree diagram first. We say, well, flipping a coin, the two initial possible outcomes are that we get a heads or a tails from this initial point. And then from here, it looks like we have all four evenly spaced areas here, 1, 2, 3, and 4. So if everything's equally likely, we could say 1, 2, 3, 4, 1, 2, 3, 4. And then also from our tails here, we'd see 1, 2, 3, 4. So I hope you could see that listing them this way, there are 8 possible outcomes in the sample space, and we need to list them in roster notation. I hope you can see how it would be helpful in having to list these in roster notation. But I hope at the same time as we're listing these here, comma, 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 I want you to see that it can be really tedious if you are actually listing in roster notation and or tree diagram notation as soon as you get like 3 or 4 or more events. So what I want to do here is just kind of have you check yourself here, see what you get with these two. So what we want to do is find the number of possible outcomes in the sample space, the set of all possible outcomes for these experiments. So go ahead, give these a shot. Flipping the 2 coins. What did you get here? What did you get? So when we talk about 2 coins, one way we can do this is tree diagram. We say heads or tails. And then from each of these we say, well, it could be a heads or a tails again. Or a heads or a tails over here once we flip a tails possibly. So our sample space, if we're listing this out, would be a heads and then a heads. It could be a heads, heads, or it could have been a heads and then a tails. Likewise, we could have said, well, we could have flipped a tails first and then a heads. So tails, heads, and then you have heads and tails. So in terms of what are all the possible outcomes for this experiment here, this would be our sample space. This would be the set of all possible outcomes for this. We can see that there exists 4 possible outcomes. And then with respect to flipping 2 coins and rolling a 6-sided die, see what you come up with here. Up here we coin flipped and then die rolled here. We flip 2 coins this time and then roll a 6-sided die. And excuse me, we have 2 coins. So with respect to our 2 coins here, what I want to do is just build on our last experiment here. And what one can see is basically this. If we were to 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, you can see the 5, 6. 1, 2, 3, 4, 5, 6. It's going to be hard to list all these here, but once we get the idea down, then we could see that, we would have a heads and a heads, was an outcome here. Heads, heads, and then we could have had a 1 through 6. So heads, heads 1, heads, heads 2, heads, heads 3, and so on and so forth down to heads, heads 6. And then likewise, we're going to do the same thing here with our heads, tails. We're going to have heads, tails 1 through heads, tails 6. We're going to have a tails, heads 1 through tails, heads 6. And then last but not least, we could have had this should be a tails, tails. I'm sorry. Tails, tails. But we could have a tails, tails 1 through a tails, tails 6. But looking at this, we would say that there are 6 possible outcomes for each of these initial coin outcomes. So we say 4 times 6, there are 24 overall outcomes in the SS, the sample space. So in the next video, we'll talk about what a theoretical probability is and how to use a sample space to help us calculate that. Cheers.